So this is going to be like the third in the series of videos that I've done on graphing. And the last time that I had a graph up here, I was doing the mass over volume for this mystery fluid. And it turned out that when we graphed the mass over the volume, that was a really easy graph to determine the slope of the line of best fit from, because I keep pointing to a graph that's not here. The x and y axis had the same scale. So each block in the x-axis had the same value as in the y. It's not always that easy. And so today what I asked you to do was to write a strategy for determining slopes, because most of the time it's not as easy as it was the first time that I showed you that. So quickly, the steps are: find two convenient points where the line of best fit intersects the grid of the graph paper, one high on the line and one low. Write the coordinate pairs. You might have heard that term used in math class. The coordinate pairs are just how we define where a point is on the grid. Write the coordinate pairs next to the points, and then substitute those coordinates into the slope equation. So now on the smartboard, I'll give you an example. All right, let's take, for example, so we have this line. This is what I want. If you can't see it, but this was done on the green kind of graph paper, and it has heavy lines for your major ticks and light lines. And what they've done here is they've just gone like 1, 2, 3, 1, 2, 3, 1, 2, 3. So I can actually see, I don't know if the camera can see this or not. There is actually a light green grid that's a little bit finer than the coarse grid that they've shown here. So when I say that x and y have two different scales, this is what I mean. And I'm going to try to use the red for the x values and the blue for the y values. I want you to number yours like this also. Let's go by threes. 3, 6, 9, 12, 15, 18. And then on the y-axis, let's go by 15s. 15, 30, 45, right? Have I got that right? 60. Okay. Now let's pretend this is a real graph with some real data, not just x, y. Let's call this some sort of a speed graph. Let's call it a speed of a small airplane, since Mahia's here. He can appreciate this. And the airplane goes some distance in a certain amount of time in minutes. So it's going to be time in minutes, distance in kilometers. Okay, so we have a real live graph of a real live situation. I'm going to try to make it real. Okay, so I want to know what the slope line is. If I know what the distance per time is, then I know what the kilometers per minute is. I know what the speed of the airplane is. So the speed of the airplane is just whatever the slope of this line turns out to be. So let's figure that out. This is a situation where the scale on the y-axis is not the same as the scale on the x-axis, and so you can't just count blocks and come up with the right answer. So I'm giving you a strategy, tried and true, that you'll always get to the right answer if you do it step by step. So the first step says that pick 2 points on the line that fall right on the grid. And again, you might not be able to see it, but there is a intersection of grid points right there, and there is an intersection of grid points right there. And I picked those 2 points because there's an intersection of a grid point, and it lines up on one of these integers. Step 2, write the coordinate pairs next to those points. So for this point and this point. Now, you might ask, okay, I'm going to write down x1, x2. Which one is 1? I think I know what x and y is, but which point is the first point, which point's the second point? It doesn't matter, as long as you're consistent. This one, they usually pick the higher point. They usually say the higher point is 0.2, and this one is 0.1. So let's start with the higher point, and we're going to write the coordinate pairs for that. And the x is, this is x equal to 18, and y is equal to, it's 1, y is equal to 55. Again, you would be estimating if you didn't have these intermediate blocks. I can just look over here and see that that is 1855. This point right down here, the x-coordinate is at 6. You can see that. Right there's the 6. And then the y-coordinate is at 15 right here. So these are the coordinate pairs for those 2 points. Usually they will put these are brackets. But again, this is point 2 and this is point 1. Maybe it's good to label that, because what I'm going to ask you to do is on step 3 of our strategy is to substitute those coordinates into the slope equation. What is the slope equation? In the first or the last video we had slope is equal to rise over run. And you remember that from, I don't know, you're supposed to learn this in middle school. And how do you remember this? You have to rise up in the morning before you run out into your day. I don't know how you remember that. Right? Rise over run. And then we got a little more sophisticated with our symbology. And last video we said that was delta y over delta x. And we learned that that symbol delta just means a change in or a difference in. So the change in y, how much did it change in y over the change in x? That's what we're going to figure out. Last time it was pretty easy. We were just able to count blocks. Now it's not so easy to count blocks. I don't know. Maybe there's somebody in this classroom that already has figured out what the slope of this line is. Don't raise your hand. Don't say anything out loud. We're going to get to the answer mathematically. Okay? By using the slope equation, which is y2 minus y1 divided by x2 minus x1. You've already written this in your notes. I've asked you to write that on there. All right? So now if I just substitute these values in the equation, this is my point 2. So my y is in blue. So it's going to be 55 minus my y value for x1 divided by, switching over to a red pen, my x2, 18, minus my x1, which is 6. Okay, this is a division problem. Put the equal sign back. And now we do the math. 15 minus 5 is 40. Divided by 18 minus 6 is 12. You can simplify 40 over 12 to, I think it's divided side by 4, 10 over 3. Leave it in fraction form or make it a decimal, 3.1, something. Yes? Where did the 40 come from? The 40 is the difference in the y value. So if you were to take, let me do it in green. If you were to look, let me do it this way. Before, I kind of had you do a triangle right here, and I just said, what is this difference y? What is that difference? That is the change in y. Well, the change in y is the 55 minus 15. We know it's 55 here, it's 55 here, and it's 15 here. So the difference, the change in y is equal to 40, which is 55 minus 14. Again, I'm just telling you, we're doing this mathematically, where before we were just kind of doing it visually and counting blocks. So your next question is, well, if you don't know where the 40 came in, how do you know where the 12 came from? The 12 is the difference in x, right? So the 12 is the difference between, hey, I'm at 18 now, I started at 6, and the difference is 12. Okay, this is your delta x, and it is equal to 12. And then you just simplify the equation. So the slope of this was, all right, so this is a little more rigorous approach. I like that word. Rigorous means you have to think, right? Rigorous means you have to think and you have to use computational thinking, which is called mathematics. There's one more thing I need you to be able to do to complete the classwork at the end of the period, and that is to interpolate. And I realize that some of you didn't learn about interpolation either when you were in middle school. So now, without raising your hand or shouting out, I want you to tell me how far the airplane goes after 15 minutes. How far does the airplane go after 15 minutes? Think about that for a minute. if this was a line of best fit, we would have had, all kinds of data here that we would have had to draw this line of best fit through. And in the case that I'm asking you about, after 15 minutes, we don't have a data point, so we really can't look at our data table and figure out how far the airplane went. But we do have data for 12 and 18, say, so we can interpolate. And by interpolation, this is all that I want you to do is to go to 15 minutes. I ask you how far did the airplane go at 15 minutes. The only thing we know is at 15 minutes. Here's time, 15 minutes. Then I want you to go up to your line of best fit. And then when you touch it, then take a hard left turn and go all the way back over to your y-axis. And that tells you how far the airplane went in 15 minutes. You've interpolated. It went a distance of 45 kilometers. This translates to a little bit over 100 miles per hour, which is not bad for a small airplane. Okay.